Hello everyone, this is Tariq Time, and today we're going to cover the first topic of IB Physics HL curriculum. It is called an A1 Kinematics, and to be specific, the small portion of it, which is describing motion, vectors, and scalars. Now, at the end of the lesson, we're going to answer to this question: how to always be on time. Yeah, to understand the concept of vectors and scalars, we need to look at this example. So here, our point A, which is the house, is our starting point. Now imagine that you're leaving your house and imagine your typical road to your school. You're waking up at 8 o'clock, you're brushing your teeth, and then you're leaving your home. We can imagine that here we have some kind of a bus stop and we're walking towards it, and then we sit at the bus, which goes somewhere here, and then maybe here, and then we have the bus stop of our school, and eventually we'll came to school. In this situation, our scalar quantity, which is a distance, will be our every turns and our every distances that we're covered. So this is our distance by foot, the whole distance of the bus, and also this small portion. All of this road will be counted as a distance. For example, we have walked here 1 kilometer, here the bus traveled for 5, this again 1, and the total our distance is going to be 7 kilometers. But the displacement, which is a little bit different, which is a vector quantity, is going to be this distance. Now, as you have understood, displacement is much more smaller than distance. I mean, you can clearly see that this portion is much smaller than this one. This could be about a 5 or something. And yeah, but that's not always the case. We are going to discuss it at the end of this video. Now, from this situation, we can make a small conclusion of how to identify what is meant by scalar and what is meant by a vector. Now, according to the book of Course Companion by Oxford of 2023, they have given this kind of definition for scalar and vector terms. So scalar is a physical quantity that has size but no direction. And the vector is a physical quantity too that has a size and direction. In your IB physics exam, you'll not have this kind of questions, but this is fundamental concept that you need to understand if you're taking a physics HL exam at the May of, I don't know, maybe November. And now, how to label them. So in order to label vector physical quantities like displacement, in this situation, if we are going from our house to the school, our notation will look something like that, with the arrow at the top. So we're going from A to B, but if you're going back to home, it is going to look something like this. So in the vector quantities, we're always put an arrow towards the end of location, but in the distance, we're going to write just BA or AB here. Now, let's solve some questions related to this topic. The ball is dropped from an initial height of 1.2 meters. After hitting the ground, it bounces off by 75% of initial height. Calculate the displacement of the ball and B, the distance of the ball. So here, the ball drops from a height of 1.2 meters, bounces back by 75%. So our displacement will be this small portion. Let's calculate it. So we have 1.2 multiplied by 0.75, which gives us, let me turn my calculator, 75, 0.2, so equal to 0.9, but there is not the displacement. We need to also subtract from 1.2. We'll get the 0.3 meters. That is actually the wrong answer, because our ball is dropped from the height and displacement should be minus. This indicates that it's been dropped downwards. Now, what is distance that the ball has traveled? As we have told, it is going to be whole path of the ball, not like the shortest distance. And it doesn't have direction show, so it cannot be a minus. So our distance is going to be 1.2 plus 0.9, which is 2.1 meters. Because it has traveled downwards for 1.2 and again up for 0.9 meters. So this is the answer. So going back to our initial question, how to always be on time. You need to always pass the displacement. You need to always pass the shortest distance in order to get to your final point. Thank you for your attention.